All right, all right. Welcome. This is Q&A Live Thursday, March the 9th. If you can check this out, I would go ahead and get online and look at it. Now, if you are currently in my Algebra 2 course, especially, but really I'm having a lot of different kids I'm tutoring. You might be at like a homeschool academy type of situation. You might be in a public or private school. I'm having a lot of people who are trying to get a handle on rational expressions, how to factor them, or not how to factor them, I guess how to simplify them, how to add them, subtract them, multiply, divide. And then the most difficult one for a lot of our kids, and to be really honest, is when something called rational expression equations. I mean, that's in a sense, I'm throwing the kitchen sink at you when we get to that particular lesson, because you not only have to understand essentially the concepts of fractions and how you have to have common denominators in order to add or subtract them. You definitely have to know how to factor your polynomials really well to have success in this unit. But then you also have equation solving, and it's all kind of like merged together. You got to figure out when to do what. So this is when you're really starting to become an expert at the algebra level. You know, this topic really throws a lot your way. So what I'm actually doing at the moment is I'm tagging some people on Facebook, some of my clients or parents of some of my clients I know. Let me see. I know who really could stand to benefit from this video, and I'm just trying to do that really quickly. Then I'm going to go ahead and give you an example or two on on what we're covering this week. This has been a challenge, and you know, it's supposed to be a challenge. Not everything's supposed to be easy. You know, we don't need to run away from difficult things. Sometimes we just need to hang in there. Okay. Sometimes we just need to hang in there. So, you know, I was just reading this morning where it says, consider it pure joy when you go through various trials and tribulations, for the end you will reap a blessing if you do not give up. So we're not going to give up today. So anyway, I'm going to cover rational expression equations first. I have some other people who are doing different things. Maybe you're in my Algebra Made Simple course, and we're working on some factoring skills. I'm going to cover that as well. But I'm going to start with the rational expression equations because I have so many of my clients who are currently trying to tackle this, you know, during this season or period of the year. Okay. So I went back to the drawing board because after teaching this unit a certain way, I realized there might be an easier or a different approach that will help some kids. There's usually 2, 3, 4, few different ways you can solve some of these problems. There's not necessarily just one way to do it. I'm trying to train your mind how to think. And I'm trying to give you the tools that you need so that you can get the job done. You know, who's going to build a house if you don't have hammer and nails and screwdrivers and all these tools ready to go? But when it's time to build a house, you need to know when to use what tool to get the job done. And so we've been giving you tools like how to factor. We've been giving you tools like how to add and subtract rational expressions, which is really built on the tools of knowing fractions and how to do operations with them. We've given you tools on how to do inverse operations to solve equations. Now we got to know when to do what tool, if that makes sense. So what we're going to do is I'm going to look at one of the problems I think I gave my Algebra 2 group in particular for homework at one point. And what I've done is I've looked at a few different approaches, and there's another method. This is a totally different way of solving this particular equation. This is a rational expression equation. Why? Because there's an equal sign, equation, equal sign, equation. It's that simple. A rational expression is essentially a bunch of fractions that have polynomials. Okay. So that's Chris Moore's definition. So you got polynomials that are in fraction form. You have some operations happening, an equal sign. That makes it a rational expression equation. Now, in class, what I've been teaching you, and there's nothing wrong with this method, it just sometimes can be long. We talked about how, hey, first you want to look on the side that maybe has addition or an operation happening and going ahead and getting common denominators. Now, what I'm going to teach you today is a shortcut. I saw this on a YouTube video. A guy had another way of doing this, and I had never considered it, but after listening to it, I was like, well, does that mathematically sound? Maybe it'll help our kids. This is a new way, new method. So pay attention and watch this video as many times as you need to. We have 18 over 5x plus 10 plus 4 over 5 equals negative 6 over x plus 2. Now, in the times past, I've told you to just try to get common denominators, but what we're going to do is do something a little different. I'm going to put parentheses around this entire equation. And what I want you to think about is what would be the lowest common denominator that all of these denominators here go into. I'm really trying not to say my denominator accent, not an accident, accent, but I just did it. All right, 5x plus 10, 5, and x plus 2. What do they all go into? What's the lowest common denominator? Well, if you think about it, the lowest common denominator that all of them would go into, multiply into, would actually be 5x plus 10, the same as this first denominator here. Why do I say that? Because you could easily multiply 5 times x plus 2, for example, and it would equal 5x plus 10. You could multiply x plus 2 times 5, and you would get 5x plus 10. You can multiply 5x plus 10 times 1 and get 5x plus 10. Therefore, 5x plus 10 is the lowest common denominator that goes into all of these particular denominators here. Now, I want to go ahead and do this so you can see the visual. Remember, a binomial such as this could be factored. And I think I'm going to go ahead and factor it so you can see that it's the same thing. For example, the GCF would be 5, and that would leave you with x plus 2 if you divide both those terms by 5. So 5x plus 10 and 5 parentheses x plus 2 is really the exact same thing, okay? This is 5x plus 10, but this is 5x plus 10 in a factored form. Now, there's a reason I'm showing you both here. It's because of what we're about to do next. Now, look very carefully, okay? I just realized y'all probably can't hear me. Can y'all hear me? Oh, no. This is what happens when you go live. Can you hear me? I got to check my mic here real fast. If anyone's watching, help me out on the audio. Make sure this is working. Okay. Sometimes I forget what I plugged in and what I didn't. Okay, so if you can hear me all right, you might have had to turn up the volume here. You'll notice that 5x plus 10 is the lowest common denominator between all three of these denominators in the equation. The factored form of 5x plus 10 is 5 parentheses x plus 2. Okay? Hopefully y'all can hear me all right. So what I want you to realize is you can actually cancel out if you look at top to bottom. For example, look at 18. Okay, look at this one right here. 18 over 5x plus 10. Well, since there's a 5x plus 10 being multiplied to all three of these terms, theoretically, you could cancel out 5x plus 10 top and bottom when it comes to this 18, and you would be left with just 18 there, okay? Because if you multiply that to all three numerators, you could actually cancel out top and bottom there, and 18 would be left. When it comes to 4 over 5, remember, you're multiplying that by 5x plus 10, but in that instance, I think it would be wise to look at it in the factored form. You got 5 parentheses x plus 2. Imagine that 5 parentheses x plus 2 is being multiplied, or it's right next to the 4 in the numerator there. Well, if that's the case, you notice the 5s cancel out, right? You'd be left with 4 parentheses x plus 2. If you multiply that out, that's 4x plus 8, right? Distribute 4, that's what you'd have left. Now, the same thing with this, negative 6, okay? If you got negative 6, I'm going to put the 5 back just to make my point. If you have negative 6 and you multiplied it by this factor of 5x plus 2, you would actually realize top to bottom the x plus 2s and the x plus 2 top and bottom, then they cancel out and leave you with negative 6 times 5. Well, that's going to be negative 30 because negative 6 times 5 equals negative 30. So this is a method that I hadn't shown you guys in class that I thought might be worth your view, okay? So keep in mind, all I did is I distributed, or at least put the 5x plus 10 next to imply multiplication to all the numerators, and then I canceled out anything I could top and bottom. And this is what I would be left with. Now, at this stage, this is actually pretty easy. This is just a multi-step equation. You got 18 plus 8. Bring down the 4x. 18 plus 8, I believe that's 26. So I'm going to say plus 26, and then bring down everything else. Simplify that equation. You'd have to minus 26 on both sides. And so that's going to leave you with negative 56 equals, positive 4x. Your last step would be to divide both sides by 4. And so x would equal a negative 14. Okay, x would equal a negative 14. So this is totally a new way. I'm going to leave it up there so you guys can just take a picture, pause the video, look at that real carefully. But I wanted to share this with you, and we will definitely go over this method during our class sessions together for those who have specific questions. But I wanted to put a video up to show it. Kind of interesting, right? You find the lowest common denominator that all of the expressions have, and then you basically multiply your numerator by that lowest common denominator, cancel out. It's just another way you can go about it, and you don't have to, in a sense, do the addition rules that you saw in the past. Sometimes it'll save you some time, and you just might like it. Okay, so moving on. this isn't the only subject I want to cover, but that was rational expression equations, just to give you an example. Now, if you're taking my algebra made simple, or frankly, if you're just really in any algebra course, this is just a tool. I mean, to do what we just did at times, you're going to have to know how to factor what are called quadratic trinomials. Specifically, when the a value is larger than 1 is what I wanted to look at today. So what I'm going to do is I'm pulling one from your homework. You got 2v squared, just writing it down real fast, plus 11v plus 5. And we were working on solving by factoring. So I'm going to change it to equaling 0 just to kind of make my point here. Okay, so I wrote this down. This is a quadratic. You can see this, all right. This is a quadratic trinomial because the degree is 2, quadratic. There are 3 terms, trinomial. Is there a GCF? That's always the question you got to ask. You got 2, 11, and 5 as far as their coefficients. There's not really anything other than 1 that they have in common. However, notice that the 2 is in front of the v squared. Remember, the a is that first coefficient, and it's greater than 1. If you ever look this stuff up on Google or YouTube to watch teaching videos, they're going to have that little extra little information. This is specifically when the a value, meaning the number in front, the coefficient, is not just 1v squared or x squared. It's going to be 2v squared or 8v squared. So when we have that, the method that we've been working on, I call it the AC method. And that's when you have the A, the B, and the C, right? The A and the C refer to the first and the last numbers. So the coefficient 2, the constant at the end, you multiply those out. 2 times 5. 2 times 5 is 10. So our AC is 10, right? The B is, of course, the middle coefficient. So in this case, 11. And this part might be familiar to you. Remember, we're always looking for what multiplies to the AC value and adds to the B. And after some thought, I'm thinking 10 times 1 equals 10, and 10 plus 1 equals 11. So these right here are going to be my winning numbers, okay? Now, it's not a bad idea to add little variables there. Call it 10v and 1v, because that's what you're going to end up having to put in with the rest of this. Now, as a reminder, after you find those two numbers, you want to rewrite the original polynomial, but we're going to replace 11v with these two numbers we just came out with. So in other words, that'll be 2v squared plus 10v plus 1v, and then you bring down the plus 5. And what we've effectively done is we've changed this from a 3-term polynomial to a 4-term polynomial. Why would you want to do that? Because 4-term polynomials can be factored by a process called grouping. So I'm going to group with parentheses the first 2 terms and the next 2 terms, and then you basically factor by GCF in each group, okay? So the GCF between these two would be 2v. Divide that out. That's going to be v plus 5, I think. And then this one, really, if you look at it, there's not really a GCF between v and 5 other than 1. So with grouping, I just say make the GCF 1, and then that'll stay v plus 5, because anything divided by 1 is still itself. As you've heard me say in class, if you're doing it right, you should have what are called common binomial factors right here. These two parentheses should have the exact same things inside. If they're the same, they're called common binomial factors. That means you're doing it right. It's a good check point to know that you're on the right track. All you have to do is put that 1 time underneath in parentheses, and then our GCFs here, the 2v and the 1, they go in the other parenthesis. Positive 1, so I'm going to say plus 1. And now you have factored this particular trinomial that had a leading coefficient. Now remember, this week we were working on taking it a step further, not just getting the factors, but doing the process of solving it by factoring. See that equals 0 there? That tells you got to solve it. So once I got my factors, set it equal to 0, v plus 5, for example, set it equal to 0, solve that. If you minus 5 on both sides, you know that's going to equal -5. That's going to be one of your answers. Pretty simple, right? But listen, if you got 2v plus 1, you set that equal to 0, you're going to have to minus 1 on both sides. That's going to leave you with 2v. I don't know if you can see that. 2v equals a -1. Don't forget, you got to divide by 2. So that's going to end up equaling -1 over 2. So I'll just put it over here because I'm running out of room. Okay, so when you have a coefficient in front of your first term, know that after you like -1 to both sides or whatever the inverse operation is, you usually got to divide by that coefficient. So a lot of times that means you have a fraction or a decimal or something as that particular answer. So anyway, Just thought this could be helpful as you're working through your work or you're trying to struggle through and reason through it. It's not easy. It's not supposed to be, but we don't give up just because something's hard. When the going get tough, the tough get going, right? But we don't give up. You will reap a blessing. You will build understanding. Your thinking and problem solving skills will develop, and it's going to help you with all kinds of challenges you face in your young life, even if you don't have to, I don't know, solve a rational expression equation in your profession. The problem solving skills, the critical thinking skills is only going to serve to help you. You don't know what problems you're going to face in this life. We don't know what problems we're going to face probably in a year, yet alone by the time you're an adult out of the house. So you need to learn how to think. People who know how to think will always be able to have a future, and that's what it is. So anyway, hopefully this helped. Leave a comment if you have a question or just something good to say, and I'll catch you guys in the classroom. Peace.